Welcome to The Explainer. Today, we're tackling one of the biggest questions in all of finance, a question that literally unlocked trillions of dollars and even nabbed its creators a Nobel Prize.
Now, that might sound like a riddle, right? But it's actually a super practical problem. Just imagine you could place a bet on where a stock will be a year from now. How on earth would you figure out a fair price for that bet today, before any of it has actually happened? Well, that's exactly the puzzle we're going to solve together. To get there, we first have to get familiar with a really clever financial tool that's at the very heart of our story. It's called an option. And trust me, it's the key that unlocks this whole thing. Okay, so here's our main building block, the call option. It gives you the right, and this is the important part, but not the obligation, to buy a stock at a price you both agree on today. Let's call that price X. Now think about it. This option is only valuable if the stock's final price ends up higher than X. If it doesn't, you're not forced to buy it. You just walk away, and the option is worth zero. Simple as that. So that's the basic theory. But to really get a feel for how we can price this thing, let's build a little thought experiment. We're going to imagine the simplest possible future you can think of. All right, picture this. We've got a stock, and right now it's trading at 50 euros. And in our little made-up world, 1 year from now, only two things can possibly happen to its price. Just two. Okay, so in path number 1, the stock jumps up to 56 euros. In path number 2, it drops to 46. Now, remember our call option? It gives us the right to buy at 50. So if the stock hits 56, our option is worth 6 euros. That's the difference. But if the stock falls to 46, well, you wouldn't use your right to pay 50 for something you can get for 46. So the option is completely worthless. So now we know the two possible endings for our option story. It's either worth 6 euros or it's worth 0. And that brings us right back to the million-dollar question. What should you pay for it right now? And this is where the real genius kicks in. The breakthrough idea is something called the hedge ratio. You can think of it like a magic recipe. It's a simple formula that tells you exactly how to mix the stock and the option together to create a portfolio where the future value is 100% certain. It completely wipes out all the risk. This is honestly the secret sauce to the whole thing. If you sell one option, the hedge ratio tells you the exact number of shares to buy so that you're perfectly balanced. It doesn't matter if the stock goes up or down, the final value of your combined portfolio will be exactly the same. You've created a perfect risk-free investment. Let's just plug in our numbers and see. The total range of outcomes for the option is 6 euros, right? It goes from 0 to 6. And the total range for the stock is 10 euros, from 46 to 56. So we just divide 6 by 10 and we get our magic number, 0.60. That means for every option we sell, we need to buy 0.6 shares of the stock to be perfectly hedged. And after we build that risk-free portfolio and figure out what it's worth today, we land on this exact price, 3.714 euros. Now, this isn't just a guess. It has to be the price. Why? Because if it were any different, say 4 euros, you could sell it, build this risk-free portfolio, and pocket a guaranteed profit with zero risk. That's called arbitrage. And in the real world, those kinds of free money loopholes get slammed shut almost instantly. Okay, a future with just two paths is a great way to wrap our heads around the logic. But, reality is a lot messier than that. So how do we scale this idea up? Well, let's see how this simple concept can grow into something way more powerful.
So what we just did, that's called a one-step binomial model. Pretty fancy name. But all it means is we have one starting point today that branches out into two possible outcomes tomorrow. Simple, clean, and really powerful.
But here's the cool part. We don't have to stop there. We can take each of those two tomorrows and let them branch out again. So now we've got 4 possible outcomes. And the amazing thing is, we can use the exact same risk-free hedging logic at every single node of this growing tree. And you can see the pattern here, right? The more time periods we add, the more possible futures we can account for. The number of outcomes just grows and grows. But the key is that the method never changes. We always start at the very end of the tree, where we know the final values, and then we work our way backward, step by step, to find the fair price all the way back here today. So this tree model is awesome, but it's still a bit clunky. It moves in these discrete jumps. So here's a wild thought. What happens if we slice those time steps into smaller and smaller and smaller pieces? I mean, millions of tiny steps, creating a totally smooth, continuous path of possibilities. Well, what you get is this.
The legendary Black-Scholes formula. By using the power of calculus to make those time steps infinitely small, the model transforms our clunky branching tree into a smooth, beautiful curve. This one equation takes that core logic of risk-free hedging and applies it to a world where prices are always moving. It's the master key.
And I know it looks super intimidating, but its ingredients are actually pretty intuitive. You've got the current stock price, the price you agree to buy at, the time you have left, and interest rates. But the real secret ingredient, the game changer, is volatility. And that just makes sense, doesn't it? The more a stock swings around, the higher the chance it could end up way above your purchase price. And that makes an option on it much more valuable.
Now, this is way more than just a cool academic exercise. This model actually provides an entire toolkit for understanding and actively managing risk in the real world.
You know, one of the most critical things that comes out of the model is a value called delta. Think of it as the real-world version of that simple hedge ratio we calculated earlier. It's a dynamic, live number that tells you exactly how much an options price is expected to change for every $1 move in the stock. And this is precisely how traders use the model, every minute of every day. If you're running a massive portfolio of options, you are constantly watching your delta. It tells you exactly how many shares of stock you need to buy or sell to completely neutralize your risk and get back to what's called a delta neutral position. So, we started this journey in a simple, two-path world and ended up with a single formula that powers global finance. We've seen how the incredible idea of a risk-free portfolio can take the sheer chaos of the future and boil it down to one precise number. But it kind of leaves us with one last big question. If we can put a price on uncertainty, does that mean we can actually control it? Or does it just give us the confidence to take on far more risk than we ever should?